as is often the case in calculus, once we learn a new way of doing something or a formula, we love to apply it and see how it would work in physics, for example, especially physics, since Newton did a lot of this stuff. All right, so we know that work is the force vector dot product with the distance vector. And we also know that that would be the magnitude of the force vector times the magnitude of the distance vector times the cosine of theta. Right? So we know those pieces. And we're going to use that in order to solve a physics problem. We're going to play with the angle of our force vector. So we have a force of 16 newtons acting at a 28 degrees to the horizontal, pushing a box 25 meters along a floor. All right, so let's see here. We have a floor. We have a box. This is going to be a terrible drawing. So here's our box, and we're going to move that box along the floor to a new location over here. Okay, so, let's see what we've got. We know that the force, or the distance, is 25 meters. So that's 25. No trouble. Meters. And now we have our force vector coming in at an angle. And we know that the force is 16 newtons. Now the angle, the 28 degrees to the horizontal. So the horizontal is right here. So the 28 degrees is right here. There's our angle theta. Now in this particular case, because we know the angle theta, we're going to use that form of the dot product. So we're going to use the force vector, the magnitude of it, times the magnitude of the distance vector, times the cosine of the angle. Okay, well the magnitude of the force is 16. The magnitude of the distance is 25. That's newtons, that's meters. Right? And then cosine of 28 degrees. All right, so let's go to Maple and make Maple do this. Okay, so first thing I want to do is I want to come up with that angle. Oop, hold on, I'm going to give myself some more space to work in here. There we go. And I'm going to make my font size larger so you can see it. I'm going to try A1, or excuse me, A3 colon equals. So example 3, angle 1, I'm just coming up with it. And I'm going to convert, oops, not covert, convert from 28, type the word degrees, comma, radians. Enter. All right, there it is. It knows what I want. All right, so now I want it to come up with 16 times 25 times the cosine of angle A31. Now, because I did the angle in exact mode, it gave me this 7 pi over 45, and so therefore it's giving me an exact answer, which isn't really what I want, right? I want a decimal here. So one thing I can do, I mean, there's a couple ways you can do this. You can use the approximate feature over on the right, or if I'm doing more with this, then I might actually want something a little bit more. So I'm going to go 28.0 degrees. By putting in a decimal point, I'm tricking it. Oops, I have to hit the right button though. Hold on, I just messed up. There we go, 28.0 degrees. There we go. And I'm going to hit enter. And now it gives it to me as a decimal. So now when I go to run this, it'll automatically change it to a decimal. So I'm just going to make the font big enough you can see it. So there we go. So we know that it's 353.18. Okay, so from Maple, 353.18. Now the units get students a little confused. This is newtons, this is meters. They're multiplied, right? So it's Newton meters. In other words, it's joules, right? Newton meters is a little awkward, and somebody else thought of it, so we're going to call it joules. So you can say Newton meters, right? It's not divided, it's multiplied. So newtons times meters, or Newton dash meters is how they write it in physics. And then that's joules. All right. Also known as joules. Okay, so now let's come up with another example. We have a force in pounds that moves an object from this point to this point, assuming the distances are measured in feet. We're going to find that work. All right, well, work would be the force vector dot product with the distance vector. And I know the force vector. It's 3, 1, 6. I don't know the distance vector, but I could find it. I don't need the angle, right? We don't know the angle. So let's make a little note, right? The angle was not given. So we're going to use the alternative method. The one that doesn't involve theta. All right, to do that, I'm going to need my distance vector. So distance vector would be from P to Q. And remember, we get terminal, initial. So to do this, we're going to take terminal minus initial. So we're going to take 4, -1, -2, and we're going to subtract the initial, which would be 1, 1, -5. I'm just kind of making them into vectors, but you could wait and make it to a vector at the end. It's no big deal. So 4 take away 1 would be 3. -1 take away 1 would be -2. -2 minus a -5 is -2 plus 5, which is 3. So over here, my distance vector is 3, -2, 3. And so for the work, we're going to use the alternative method. 3 times 3 plus 1 times -2 plus 6 times 3. That's 9, take away 2, plus 18, which is 25. And now the units, think about this. This was feet and pounds, and they're multiplied, right? This is a dot product, so it's foot pounds is how they abbreviate that. Now another simple type of application would be to find the angles between, the angle between the vectors, in which case you would solve for theta in this particular formula. Okay, so let's look. We have r, which is -6, 1, and we have t, which is 4, 2. So let's just think about what that looks like for a second. So here's your coordinate axes. You have r, which is over -6 up 1, which is like this. So that's your r vector. And you have t, which is over 4 up 2. Like that. Theta is the angle between the two of them. Theta is that angle. Okay, well, let's think. We know that r dot product with t is equal to the magnitude of r times the magnitude of t times the cosine of theta. All right, so r dot product with t would be -6 times 4 plus 1 times 2, using the alternative formula over on the left side. The magnitude of r is the square root of -6 squared plus 1 squared. The magnitude of t is the square root of 4 squared plus 2 squared. And then the cosine of the angle we're just going to leave there. All right, this is -24 plus 2, so that's -22. This is the square root of 37. This is the square root of 20. All right, so the cosine of my angle is equal to negative 22 divided by the square root of 37 and the square root of 20 multiplied. So theta, more or less, is the arc sine of that angle. Now, it might be a reference angle. Actually, this one I think is going to work out. But just keep in mind that not always do these give us the correct values, because arc sine is restricted to quadrants 1 and quadrants 2. All right, so I'm going to give myself some more space in here to work. I'm going to close example 3a. I'm going to enter a new section, which is example 4a. And then I'm going to type all this in. So I want the arc sine of, arc cosine, excuse me. I wrote sine, but I meant arc cosine. I'll have to fix that. Arc cosine of negative 22 divided by, and we want the square root of 37 times the square root of 20. Close my parentheses. Now, it found it, but it's not pretty, right? It's not going to work out nicely. So one thing I can do is kind of tweak this, put some decimal points in so it at least gives me a decimal answer. All right, that's still pretty ugly. The next thing I can do is tell it to approximate. So I can say, hey, this isn't working. Give me an approximation here. And it'll give me approximation. Lovely. But that's radians. Oh no. Okay, so I can say, hey, I don't want radians. So take that answer, which is section or label 2.2. So I can insert a label and say, give me that answer 2.2, but this time give it to me in degrees. Oops, I have to write the word degrees and close my parentheses. And there we go. It's 143.9, so 144 degrees, roughly. And so sorry about that arc sine. I don't know what I was thinking. It's arc cosine. All right, so this is 144 degrees, roughly. Which makes sense, I mean, when you look at it. Right, it's an obtuse angle, right? It's not quite to 180 degrees, so this makes perfect sense. All right, let's do another one. So this time we have both vectors actually in quadrant 1. I don't know if you noticed. These are, oh, and these in octant 1, as a matter of fact, octant 1, because these are three-dimensional. So you just make a little note, right? Both the vectors. We won't be able to draw this one because it's three-dimensional. So we're just going to make a note of that. Because everything's positive, so they must both be in octant 1. Okay, all right, so we'll use the same idea that we did on the last one. So U dot product with V, U dot product with V is equal to the magnitude of U times the magnitude of V times the cosine of theta. I'm going to put a little vertical line in, or excuse me, horizontal line, so that I can make sure I keep my problem straight. Okay, U dot product with V would be 3 times 1 plus 0. There's no J component over here. So 0 times 2 plus 5 times 4. That would be equal to the magnitude of U, which is the square root of 3 squared plus 5 squared, times the magnitude of V, which is 1 squared plus 2 squared plus 4 squared, all under a square root, times the cosine of theta. Okay, so over here this is 20 plus 0 plus 3, so this is 23. This is the square root of 25 plus 9, so 34. This is the square root of 16 and 4 and 1, so that's 21. Cosine of the angle. All right, so again, if the cosine of the angle is equal to 23 over the square root of 34 times the square root of 21, then theta must be the arc cosine, there we go, of 23 over the square root of 34 times the square root of 21. And we will just make Maple do it. So I take it back. I'm going to let this just be example 4. And I'm going to do kind of all of this over again. Sometimes in my sections it can be a little weird, so I like to do a lot of enters to make sure that it really gets it. Okay, so I'm going to copy and paste this arc cosine because why not? It's not negative. It's 23.0 divided by the square root of 34 times the square root of 21. Enter. All right, again, it's giving me this kind of weird answer, so I can just say to it, hey, give me an approximation for that, and it does. That's in radians, so now I want to convert, but the label I want to convert is 2.5. So I insert a label and tell it 2.5, enter, and then it'll give me that result. So it's about 30.6 degrees.